Our speaker is from Universidad Federal de Pará in Brazil. His name is Pedro Walfir. He's a geologist and he has a PhD in coastal geology and remote sensing. And he has been a professor at the Universidad Federal de Pará in the Institute of Geosciences since 2002. And he became a full professor since 2018, right, Pedro? Okay, so thank you very much, Pedro, for joining us this morning, or this afternoon, depends on where you are. It's the beginning of the afternoon for you, I guess, for us too. So, he's going to give us a talk on mapping, monitoring, and estimating mangrove biomass from SAR images. So, Pedro, thank you very much for joining again, and you will have about 40-45 minutes to speak, and then we have the questions and answers. We have questions from the room and questions that will come through the chat in YouTube too. So, Pedro, the floor is yours. You should be able to share it. You cannot find it? No. Sí, compartir pantalla. You have the permission, and you should. Just 1 second, they are checking. Just a second, they are chatting. So it's not working, Pedro? It should have it in the bottom of the screen. There you, oh. But you have this is a cell phone connection you're using? Admitir.
Se salió y volvió a ingresar el proceso.
Es curioso porque aparece.
Sí, se quedó girado. Sí, creo que.
No, está bien. Pedro, are you there? ¿Cuál fue el que entró al final? Oh, ahí está.
Está muteado.
There you go, Pedro. It's now. Coloca la reactiva el audio.
Sí, está listado. Esperando a Pedro para que. Ahí va a activar el otro. Sí.
That's okay now.
Let's go.
I will talk to you about mapping, recording, and estimating mangrove biomass from SAR images. It's an initiative to attend the biomass project to estimate the biomass using satellites in BIOMASS.
BIOMASS.
Yeah, BIOMAS. And so we are in the loop. And no rainfall 5 years during the last 5 years. And it's possible to map mangroves here and marshes inside the island. However, in February 9th, we acquired the image in the low tide, and we have a lot of rainfall 6 days before. What is possible to see? The backscattering increase in all environments. It's very difficult to separate mangroves from marshes, from grassland. And in another condition, we have low tide and increasing and flooding tide with no it's possible to discriminate the different environments. So we discovered that we have a very nice condition to use the C-band to map mangroves and salt marsh. We need to have independent on the tide water level. It's not a problem for us, but precipitation is a huge problem. So the better condition we have to acquire C-bands under low precipitation during the last 5 days. Only this way is it possible to separate these different land cover, mangroves and brackish marshes and water. In the literature, some authors consider the tidal range as an important environmental factor to discriminate different flooded targets. But in our research in mangroves, the key point is precipitation. Another application, we use L-band multipolarized using airborne synthetic aperture radar to map different environmental mangroves, different environmental in the same condition but different land cover mangroves. In this area, it's possible to be a very huge mangroves. The mangroves have more than 30 kilometers in length along this green area. And we acquire image in different polarization, in VV, AGH, HV, and here we have a color composite in orange, in AGH in red channel, HV in green channel, and VV in blue channel. And it's possible to map different environments, huge mangroves here, mature mangroves, and mangroves in regeneration in this point, and cutted mangroves here, where we have a soil exposition. In another site, it's possible to see mature mangroves and dwarf mangroves here, hypersaline mangroves. It's possible to discriminate these two environments using L-band tool. And here we have a full image in different composition, in different polarization. And here we have a classification of these different bands, different wavelengths, different polarization, I'm sorry. Yeah. And here we have a color composite. It was possible to map we get different accuracy assessment in the classification, and the best classification was the multipolarized composition, when it was possible to use all polarization and it was possible to discriminate all the classes with 83% in overall accuracy. Using individual polarization, the accuracy of the classification is relative lowest. So the classification of multipolarized L-band was better than single polarization. So when you choose, if you have an opportunity to choose a SAR image to map flooded environments in coastal area, choose multipolarized bands. Yeah, is better than single bands. And so the validation of SAR image through fieldwork contributed to accuracy of wetlands mapping. Fieldwork is very important to assess the land cover classification. The use of SAR plays an increasingly important role in mapping changes in coastal wetlands, and multipolarized images are useful for mapping wetlands in Amazon coast. So, in resume, the better condition is low precipitation, and multipolarization bands to use SAR. Here, we talk about monitoring. Well, in other words, how can I observe changes in mangroves a long time using SAR image? In this case, we're using RADARSAT 2 polarimetry to understand the mangrove structure. Normally, you monitor 5 class mangrove dominated by Rhizophora mango, another mangrove dominated by Avicennia germinans, salt marshes, sand flats, dunes and beaches, and mangroves in regeneration. In this case, we use a single loop complex RADARSAT 2 image in quadrupole, in 4 polarization, in the same orbiting with angle change from 23 to 25 and spatial resolution around 10 meters. It was possible to detect the main polarimetric response for different plots. The method is based on to get field work, to get vegetation structure in the field, and where it's possible to map the height of the trees, the diameter pressed, the VBH, yeah. And in the same plots, you extract a plot from single look complex image to co-polarize it and to detect the sigma naught linear. This way it's possible to extract a polarimetric signature for different targets. In this way, in the end, we use a Claude-Potier classification and Freeman-Durham classification to detect the polarimetric signature and to try to understand the mechanism of the backscattering in C-band. Here we have the signature in the upper right figure. It's possible to observe the main polarimetric response to mangrove with 100% dominated by Rhizophora mango. It's possible to have 2 different signatures, while here we have a signature from mangrove in regeneration. We have similar polarimetric signature. It's not so easy to use polarimetric signature to discriminate different structures of the mangrove forest. And the main backscattering observed in this region is related to surface scattering, where dominated mainly in this lower part of this graphic here, surface scattering, where we have a response of C-band in the top of the canopy. We have a random surface in zone 6 here, related to surface scattering too. And we observe that only in zone 5, we have important anisotropic particles related to the backscattering. So this is the problem, not the target, the mangrove, but that dominate this backscattering is the wavelengths, the C-band. Therefore, C-band is important to detect only the surface scattering. We don't have information about the canopy, about the volume scattering in the canopy of the trees. If you need to understand this mechanism in the volumetric scattering, you need to use large wavelengths. We need to use L or P band. And using Freeman-Durham, we have a similar answer. In this case, we have the volumetric scattering is dominated, followed by double bounce in the canopy of the tree, and we have a small surface scattering in the top of the canopy. And using the Sentinel-1 to monitor mangrove, this is our first experience to using Sentinel to estimate biomass. In the figure in the right side, it's possible to see some plots. In the transects is the line, and dots are the plots surveyed in the field. We have 237 plots with vegetation structure measured in the field. And in this site was divided in 12 sites, where it was possible to measure basal area, average height, median height, lower height, and biomass. And all of the information were used to estimate the biomass using allometric equation developed by biologists. Using Sentinel-1 to monitor the mangrove, it was possible to observe a time series of the backscattering along the 1 year. And we observe a very interesting process. It was possible to observe that the biomass and the VV and V8 scattering have a seasonal change related to the phenology of the vegetation along the time. The Amazon region here in the coast is very well marked by a seasonal climate. We have a monsoon climate. We have a dry season between August to December, and we have a rain season between December to April. And it's possible to observe the behavior of the backscattering along the year changing, and we have a very good information that we can use backscattering in C-band to observe seasonal and phenological change of the mangrove vegetation along 1 year. And to estimate the biomass, C-band has a problem, because the biomass estimated by C-band with 6 centimeter in wavelengths saturate around 70 tons per hectare. So it's not possible to use C-band to estimate, for example, the biomass in under-disturbed mangrove forests. We have more than 200 tons per hectare in this area. However, in regeneration mangroves area, the biomass is around 60 to 70 tons per hectare. So C-band is a very good data to estimate this. So we use C-band in this area. We define, I think, 17 plots to 15 plots to measure the mangrove structure in the field. And we define 4 different stages of the vegetation, recent stages, or is dominated by soil exposition. And later we have initial regeneration with small shrubs, intermediation revegetation, and advanced regeneration. In this case, we define the different groups of plots and qualify each plot if you have recent, initial, intermediation, or advanced regeneration. In this case, we select in each plot, we extract some SAR information related to the backscattering in age polarization, HV, VH, and VV. We generate the beta notch in age, HV, VH, and VV, and gamma linear in the 4 polarizations. And we define this backscattering to all plots and in group in different stages. This way, we can compare the vegetation structure measured in the field with the sigma, beta, notch, and gamma linear to observe what's the best parameter to be correlated to structural vegetation parameter measuring the field. So observe we have in bold the better correlation between SAR backscattering and vegetation structure. And for us, this way, it was possible to establish some linear regression to define what's the better parameter to estimate the different parameters and biomass. This way, it was possible to measure the mean DBH, the mean height, and biomass. And observe that we have here the higher shrubs is around 2 meters. The DBH is very small, around 3.4 centimeter. We have a very good relation between the produced map and observed data acquired in the field work. And here, it was possible, based on allometric equation, to estimate the biomass. That is no more than 10 kilograms per meter square or 70 tons per hectare. Okay? So the multiple regression model is a very nice result to estimate vegetation structure and biomass. Here we have a general structural attributes of the plots measured in the field, showing the grouping in different stages that we can observe. So the next step, our future trends is related to biomass and a new look to observe mangrove forest. We are anxious about to get this data to analyze the biomass estimation using SAR image. Biomass, we operate in 70 centimeter wavelength, is the first orbital satellite in orbit, and they have a very new technology named tomography. And this investigation will be done during the first 11 months, and will be possible to combine images to create a 3D map of vertical structure of the forest, including biomass and height. So it will be possible to investigate the biomass in different stratas, in the volume scattering, in the branch scattering, and the ground scattering with the double bonds. So it will be possible to discriminate the biomass in different levels. So at the first time, we will have a full polarization SARs available for us, students and researchers, to investigate the structure of the vegetation. We have X-band to investigate the surface scattering, C and L band to investigate the volume scattering, and P band with tomography to investigate all the scattering observed from the interaction between SAR and vegetation structure. And besides the biomass, we have an interferometry capacity, and will be possible to use repeated passes interferometry to measure changes in heights and forest biomass over time, which is essential to monitor the mangrove dynamics. So it will be possible to investigate the roofing of the forest along the time. And this is a very important information to understand the mangrove biomass above ground. And I'm sure that we have a very new age in the SAR studies in the next decades. I would to say that the biomass is the SAR of the dreams. It's the more complete SAR that we have in the future, that we ever have. So I would like to say thank you very much for the opportunity to share my knowledge with you. And muchas gracias, and I'm available for your questions, for your preguntas. Thank you.
Thank you very much, Pedro. Question, please?
Okay, so you could make
The sound is not so good.
okay. So
The sound is not so good.
no,
There's a
no, yeah, no,
it's cutted.
okay. I don't know much about the mangrove ecosystem, and my question goes related to the forest mentioned.
I'm sorry, but I don't understand you. The sound is not so clear.
Oh no,
There's up and down, up and down.
oh, we're trying to do this.
Just one second, Pedro.
Okay, now, thank you. No, no, yeah.
Pedro?
Ainda o som é muito alto e baixo ao mesmo tempo.
Yeah. Now?
Deixa eu tirar a tela, ver se melhora. Vamos tentar. Pode falar?
And now you can you no, see? No. Okay. Yeah, can I bring
Not so good, but that's
okay. It's in the mangrove ecosystem, some let's say type that could relate to what the European vegetation has in the deforestation vegetation that is they have for example or and
it's impossible to understand. I'm sorry.
there are some questions in the chat. Can you see the chat? The chat. I can
Pedro, Pedro, Pedro. Can you hear Pedro?
Pedro, apparently you're muted. No?
Could you call me in my cell phone? Camila, do you have my WhatsApp? Or no?
What is it? To that question, what is it?
Yeah, let me see. Let me access the using another. Okay. Hello, hello. You can write or you can say. Call me. I'm calling you. It'll be better. A lot of technologies.
Yeah.
Okay. Okay. Mm-hmm. What about us? Come on. I don't know the European Union deforestation regulation types of forest affected in the mangroves. This product is used using what kind of remote sensing data? Okay. What's the question?
¿Aló? ¿Aló?
The sound is good now. Now it's good. I don't know what you do, but it's good.
¿Aló? 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 ¿Escucha?
I'm hearing you now. Good. Yeah, I don't know this product. It is produced in what kind of remote sensing data? Optical or SAR data?
Cut out is one of the types of products that are clean in the presentation. Therefore, I wrote cut out with the cut out the marker. The accuracy for present temperature.
Yeah, but EUDR, what is? European Union Deforestation Regulation. Yeah, and what's the relation between this information with forest affected in the mangroves?
Effort of any kind before 2020, and then
Before
2020, and then you produce something like cacao, for instance, in that land, then you are in full with the European regulation for stations. So the question is, do you have any, for instance, cacao plantation or something like that that could be grown now in a land that was previously mangrove, for instance, and like that?
it's possible to use the SAR information to monitor cacao or mangroves from the next from 2020 to now and later. The problem and the use of the SAR is very important because in the Amazon the cloud cover is very constant. So the SAR is a very nice solution to monitor these types of plantation or the natural mangrove.
Look,
Thank you, Pedro, for the presentation. I think that now your environments are very interesting because they have very special kind with different kinds of instruments. And in that way, we can talk about what kind of content the outcome can be joined by heart. I would like to offer
Again. Oh my God. I will close my camera. I don't know if the traffic of information.
Totally to build the roof. Can you get where?
Yeah. Because the sound is like a
No,
Now? No.
thank you, Pedro.
you can answer later your question. Okay. Camila has my WhatsApp. Okay. Okay. Thank you very much.
No.
It will be a pleasure.
We are very sorry for the inconvenience.
Okay.
Thank you very much. We'll have to go because I think that we are in this you are following the not very quality. So we'll send you a question and then we'll pass it down. Is that okay with you?
Okay. Thank you. Stand by me if you need to use SAR for something, for some application. If I can help you, it will be a pleasure for me. Thank you very much.